I've been waiting for this moment for so many months. No, seriously. Many months ago, I made this screenshot with idea to show it to people and talk with them why it's wrong, why you don't do that, and why it's much worse than it looks at first. And today the day has come. You are watching this video, and I'm telling you what the context window is about and how important it is to understand it and to keep it under control. So let's begin. First things first, we will be understanding what is the context window for real, see how it's being filled and what problems it brings to us, and then we will learn how to keep it under control. By the way, if you didn't know, this video is a part of Kilo 101 series where we show all the best practices and teach all the most important things about AI-assisted coding. So subscribe. But let's begin. So, first thing, just briefly refreshing, what is a context? Basically everything what goes in the AI model. So system prompt, instructions, your query, all those kind of things. At first that looks not that much, but situation is actually a little bit more sophisticated. Context window is a bucket. No, again, seriously, it's just how much context, so how much input model can handle at once. And then everything what doesn't fit into this context window will be dropped, ignored, cut off, so it will never get there. So that's already one big reason to keep an eye on the current context. So your request or important files or some important data will not be just ignored. But there is much more than that. This window size was very small in the beginning. It's evolved over time, and now modern providers can offer even 1 million of tokens context window, which is incredible in comparison with what's been on the market just a year ago, seriously. But why it goes so slowly? Still, why there is not so much more offer on the market, and usually we go around 200,000 at the moment and up to million. The problem is quadratic. The point is it's to compute relationships between each and every token, and that's what model does to understand what you're asking for. Relationships between each and every token needs to be calculated, weighted. So then it takes a lot of work. And those scales quadratically, basically to handle with twice more context, twice bigger context, you will need 4 times more computational power. In real life, it's slightly more advanced than that, because although theoretically it's quadratical, there are some optimizations what developers do, teaching LLMs to be slightly better, but still maybe it's not quadratical, but getting very close to it. So it eats a lot of hardware, a lot of GPU, a lot of everything. Situation, that's the only part of a problem. There is a second part of a problem. Large language models are stateless. Each AI call is independent. That means what every time we ask something, model starts fresh. It has no idea what's been happening before. Even if you are in the middle of a refactoring and you've been taking care of that for last 2 hours, and you are in the same task, doing all the same job, each and every API call goes like from the very beginning to the model. Still, model somehow is able to continue the development, right? How it happens? The story is there is much more things going into the context than it looks at first sight. Yes, you know there is system prompt and rules, custom rules, instructions in your query. Yes, of course, but also all the additional context you provide, like files, you've mentioned it, or files, what model read during execution of the API calls, and like calling the tools, for example, output on any using tools. So if you was doing npm install, this it will have a full output of this npm install what model did, in the worst of all, entire conversation history. So model will be understanding of what is it all about. So it goes more or less like that. With every AI model call, there is a system prompt code in your question, and then there is a response trying to do something. Mostly probably will be use of some tools. So then result of the use of this tool will be delivered to the model, and then model can try to do something else. Or maybe you will give some feedback, and based on this feedback, model will decide to change something. And then there is a response on the response on the response on the response on the response, and keep counting. So context grows for every next request, and it grows quickly. What are the consequences of all of it? First of all, price, and it's worse than it looks at first. I will show you. Then, obviously, reducing focus. If the model cannot distinguish between important and secondary, something what happened before and not relevant to a current situation, like some npm install it did very in the beginning of your task. It's not relevant already, but it's really hard for a model to distinguish if it's relevant or not to what it's doing right now, many API calls later, and it's still in the context. Then, again, as model needs to understand differences and relations and how it's all connected with each and every token, then, of course, when that's getting too much, those relationships will be lost, and things will go pretty pessimistic. First, about the price, as it worries most of the developers. Take a look how price changes. Call with 10,000 tokens on the Sonnet 4 with the current pricing using killer code provider will cost you 3 cents. Like, negligible, right? During the same conversation, doing the same task, call with 200,000 tokens will cost you already 60 cents. And then keeping growing, so solving maybe already a new problem within the same task, call with 600,000 token will cost you over $1.50 each call. And serious works usually involves best case scenario dozens, but very often hundreds of calls each task, and each and every call will be more expensive. Each and every one of them. So yes, if we do call with 1.80, then next one will be 1.85, then next one will be 1.90. In this direction, it accumulates quickly. So of course, then you can meet in the internet questions like that. So I burned $40 in less than an hour. Wanna guess, did this person launched a new task? No, of course, all the job was done in the same task. That's a very common beginner's mistake, trying to doing everything in one single task. Some kind of a fear to launch a new conversation with a model. Don't do this. Don't do this seriously. Now, so accuracy declines. We already discussed it. But think again, like imagine to understand the model, you need to become the model. Imagine yourself being a model. All input, everything was sent, all the files, all terminals, or problems, or all input, everything got concatenated into one huge vector of tokens, token IDs, what fits within context window, and then already it needs to be analyzed. That's why we use XML to try to help model to understand where example ends and then the problem description begins. Sometimes it works, sometimes it doesn't, but more context there are, harder for model to understand what we are talking about. Then, of course, overloaded model, I bet you saw it, begin to hallucinate, begin to mention frameworks, methods, libraries, what never existed, and just be overly inventive. I bet you saw it many times already. So, just the fact what you can give context of 1 million tokens to a model does not mean it can handle it. And definitely doesn't mean you should do that. How we deal with the context. How we deal with the context size and the context window. Keep an eye on the context. We use new tasks very often as possible, and if we need to explain what's it about, what this project is about again and again when we use custom rules or memory bank, something like that, agents MD, I will talk about all of those things in the future episodes. Then we use condensing. And there is a trick. If condensing launched on its own, that mostly probably it's already way too late. By default, smart condensing turns on, then you're getting to 100% of a context window being full, and that means it should have been launched, mostly probably many API calls ago. We minimize data input, and we think, how do we divide and conquer our tasks? Let's take a closer look. So, first thing we want to do is the keep context size under control. Take a look. This is not a progress bar you need to fill. No, that's not a progress bar. Our goal is not to fill it. If even you are on the middle of that already a signal of a problem, but usually we try to stay like under the half, especially for 1 million size context window models. That's for sure. As we work, it will grow, and make a habit to take a look at it from time to time. Then, second thing, we not afraid to start new task. You might be tired of explaining to model what is it about, again and again and again, briefly describing your project in the beginning of each task. Of course, we don't want to do it. So create a custom rule. We will talk a lot about memory banks, agents MD, all the things like that in the future. But for now, what's important, if you're doing something new, not relevant to the previous, create a new task. You might think of that like one task per one issue, if you use some issue trackers, but usually I do actually multiple tasks per issue I work with. It helps a lot with context. Then, think about minimizing data input. For example, if you just mention terminal, many things can go into the log what you don't want to have them. It's, by the way, related to context poisoning. I will be talking in the next video. Then, what you definitely don't want to do is you don't want to put, like most of the time, you don't want to put the whole folder into the context. Do you really want to put everything in the source code folder into the context? Like pretty rarely it must happen, I guess. So then, and use more often just, instead of just mentioning file, if you work with some specific part of a file, then just select it and kilocode, add to context, and boom, you have here where is it located and what is it about. So model can begin working immediately, having already precise part it should work with, so you should not worry about it reading 200 kilobytes files if you have so. I hope you don't. Then the very important part is to divide. So as we discussed already, creating new tasks, you can do it manually, like in the last live coding I did. You saw me doing first one task architect, then second task code. So I divided one single problem, one single little feature into two tasks already. Wonderful. But then there is an orchestrator we will be discussing soon, and it will do the same job automatically. Maybe you prefer automatic gearbox to manual. It's fine. And still, even if you don't use orchestrator, you can do the same manually, and it's becoming very easy when you just get used to it like I did. and finally condensing. Take a look. So there is a thing right here. It's a button, although it doesn't really look like a button, I know. And then you push it. It will be manual call for condensing. Then there is a special subtask will be executed doing condensation of the context. You can configure it, and I will show you how. But the idea of it will take the whole story, all the context, what goes to model on each API call, and it will try to remove things what don't belong there, what can be safely removed. Again, it's a model call, so some things might be identified not perfectly correct, but that's the idea, and usually it works pretty nicely. So as you see in this case, it's been reduced from 40,000 to 26,000 tokens pretty nicely, pretty neatly. And it costed me 9 cents. Important to understand what a model will guess what's important and what's not. So my experience so far was positive, but you might want to tune it. So let's take a look on how to tune it. We go to settings and we go to context and we scroll down. There is automatically trigger intelligent context condensing. So you can disable it if you don't want it. In general, I don't recommend it. I definitely recommend you to have it enabled. But one setting here I don't like. By default, it's set to 100%. If you have it 100%, it's way too late. It should have happened significantly earlier. So I'm definitely going to decrease it to, I don't know, 65, let's say. Although working with 1 million tokens context window, having it 65 means what when you reach it, you're already paying over $1.50 each API call. That sounds not great to me. So, okay, let's keep it like that. But there is one more setting we can improve, depending on your situation. Let me show you. So we can get down to prompts, and we can switch from enhanced prompt to context condensing. Context condensing is this special task which will do condensing of your context. So you can take this prompt, walk through it, and decide if it's doing something what you want. Maybe you want to tune it, and then you can adjust it so it will work better for you if you will be smart enough to manipulate it the right way. But for real, I wish you all the best with this fine-tuning, and let me know in the YouTube comments how did you do it and how it went, and are you satisfied with the results? I'm reading through all the YouTube comments, and I'm very curious of what you writing to me, so thank you so much for all the feedback. It's all read and it's not lost in vain. So, if I'm not mistaken, that's an episode 8, and in the next episode, we are getting to a very interesting topic, context poisoning. So, that was Alex Voloshev, and thank you so much for watching this series. Set likes. The more likes we get, then the more episodes we can release, and I can wait to meet you in the next one. Thanks for watching.